Our planet holds vast regions of frozen water. This is the cryosphere. It is a world of white and blue, of immense power and delicate balance. It includes the colossal ice sheets of Greenland and Antarctica, which are kilometers thick in places. It is also the mountain glaciers, those slow grinding rivers of ice that have carved our landscapes over millennia. The cryosphere extends to the sea ice that floats upon the polar oceans, a vast shifting platform essential for life. And it is found in the ground beneath our feet, in the permanently frozen soil we call permafrost. In stark contrast, we have the anthroposphere. This is the world that humanity has built for itself. It is a sphere of concrete, steel, and glass. It is our sprawling cities, our intricate networks of roads and railways, our towering buildings, and our vast agricultural lands. The anthroposphere represents our collective footprint on the planet, a testament to our ingenuity and our ever-expanding presence. For much of our history, these two worlds seemed separate and distinct. But these two worlds are not separate. They are deeply and now dangerously interconnected. Now that promise is breaking. The intersection of the cryosphere and the anthroposphere is not just a concept. It is a physical reality in many parts of our world. Consider the high mountains of the world, the Himalayas, the Andes, the Alps. Here, communities have lived for generations in the shadow of glaciers. Their cultures, their water supplies, and their very existence are tied to the seasonal rhythms of ice and snow. We also see this intersection in the vast, cold landscapes of the Arctic and subarctic. In places like Siberia, Alaska, and northern Canada, entire towns and critical industrial infrastructure have been built directly upon permafrost. Indigenous communities in particular have a relationship with this frozen land that stretches back thousands of years. Their traditional ways of life intricately woven with the patterns of sea ice and frozen ground. Perhaps the most widespread meeting point is along the world's coastlines. Every coastal city on Earth, from New York to Shanghai, from London to Mumbai, is connected to the fate of the distant ice sheets of Greenland and Antarctica. The anthroposphere has confidently expanded right to the water's edge, creating a zone of immense human activity that is now on the front line of cryospheric change. As the cryosphere changes, it presents a cascade of direct and tangible risks to human life and infrastructure. One of the most immediate dangers comes from the thawing of permafrost. Now, as it warms and thaws, the ground is losing its structural integrity. It slumps, it collapses, and it sinks. Buildings are cracking and tilting, their foundations failing. Roads are buckling and warping, becoming treacherous or impassable. The melting of mountain glaciers creates a different, yet equally severe set of problems. For countless communities, these glaciers are their primary source of fresh water. They act as natural water towers, storing winter snowfall and releasing it as meltwater during the dry summer months. This water is vital for drinking, for agriculture, and for generating hydroelectric power. But eventually, as the glacier disappears, the river it once fed will dwindle to a trickle, creating profound water and energy shortages for millions of people downstream. Changes in sea ice also have significant impacts on human activities. As the ice recedes, these routes are opening up for longer periods each year, creating new opportunities for trade and navigation. However, this also brings new risks. Increased shipping traffic can lead to pollution, oil spills, and disturbances to fragile marine ecosystems. The most far-reaching threat comes from the melting of the great ice sheets. The sheer volume of water locked within the ice of Greenland and Antarctica is staggering. As they melt, they pour trillions of tons of water into the oceans, causing global sea levels to rise. The very existence of low-lying cities and island nations is being called into question by the inexorable melt occurring thousands of kilometers away. The rapid changes we are witnessing in the cryosphere are not entirely natural. The anthroposphere is actively accelerating the melt. The primary driver of this change is the emission of greenhouse gases from human activities. The burning of fossil fuels for energy, industry, and transportation has released enormous quantities of carbon dioxide and other heat-trapping gases into the atmosphere. The polar regions are warming 2 to 3 times faster than the global average, a phenomenon known as polar amplification. Human activities can have powerful local and regional effects on ice. The development of cities and industrial sites in or near cold regions creates what are known as urban heat islands. The dark surfaces of asphalt roads and roofs absorb more solar radiation than the surrounding snow and ice, which reflect it. Waste heat from buildings, vehicles, and industrial processes further warms the local environment. Direct industrial activities in cold environments also leave a significant mark. Mining operations and oil and gas exploration often require the construction of extensive infrastructure. Furthermore, a byproduct of some industrial processes is black carbon or soot. When this soot is carried by the wind and settles on the surface of snow and ice, it darkens it. A darker surface absorbs more sunlight instead of reflecting it, which in turn causes the ice to heat up and melt faster. The relationship between a warming climate and a shrinking cryosphere is not a simple one-way street. It is a system riddled with feedback loops, where melting ice creates conditions that lead to even more melting. One of the most powerful is the ice albedo feedback. As the ice melts, it exposes darker land or ocean beneath. This darker surface absorbs much more energy instead of reflecting it. This absorbed heat warms the surface, causing even more ice to melt. Another dangerous feedback loop emerges from thawing permafrost. For thousands of years, permafrost locked away organic matter from dead plants and animals. But as permafrost thaws, microbes decompose this material, releasing carbon dioxide and methane into the atmosphere. This is a ticking time bomb that could release colossal carbon, intensifying climate change. These feedback loops have profound consequences for people. Accelerated melting leads to unpredictable and extreme events. Rapid glacier retreat destabilizes mountain slopes, triggering landslides that destroy villages. Ice dam collapse releases torrents of water, causing catastrophic glacial floods downstream. These events displace people, disrupt economies, and cause loss of life, turning natural cycles into human tragedies. Given the immense momentum of these changes, we must face a dual challenge. We must urgently reduce the greenhouse gas emissions that are driving the problem, but we must also adapt to the changes that are now unavoidable. In regions with thawing permafrost, for instance, new construction techniques are being developed. Buildings can be raised on adjustable stilts, or piles, that are anchored deep in the stable frozen ground below. In coastal cities threatened by rising seas, adaptation will involve a combination of defense, accommodation, and sometimes managed retreat. Adaptation is not something that one city or one nation can achieve alone. The challenges posed by the melting cryosphere are global in scale and require unprecedented international cooperation. Sharing scientific knowledge, technological innovations, and financial resources is essential. Countries with advanced engineering capabilities can assist more vulnerable nations. Global agreements are needed not just for reducing emissions, but also for providing support to communities that are displaced by climate-related disasters. Ultimately, adapting to a world with less ice is about foresight and responsibility. It requires us to look beyond the short term and invest in long-term solutions that will protect future generations. While the task is daunting, human ingenuity has solved immense challenges before. By combining smart design, collaborative action, and a deep respect for the natural systems we depend on, we can learn to navigate the challenges of our new, warmer reality and build a future that is both safer and more sustainable for all.